Now, the concept is the relative refractive index. So here you can see, so relative word it gives the comparison. Therefore, refractive index of medium 1, refractive index of medium 1 with respect to medium 2. How we need to define now you can see. Now refractive index of medium 1 with respect to 2, or refractive index of medium 1 with respect to 2, or this symbol refractive index of 1 with respect to 2. That is purely you can give the same physical significance. That is refractive index of 1 divided by refractive index of 2. That is the relative refractive index of two media. Already we know that the relation between ratio of refractive indices. Therefore, N12 that equal to refractive index of 1 divided by refractive index of 2 that equal to V2 divided by V1 that equal to lambda 2 divided by lambda 1. It is just a pure constant. It will be depends on speed of light in the media or refractive indices of the media or wavelength of light in a given media. Okay. Next, see the concept loss of refraction. So here the loss of refraction point of view, first one, incident ray, refracted ray, and the normal at the point of incidence to the surface separating the two media. All are lie in a same plane. Means if you are taken all light rays in different planes, the Fermat principle will not value. So if you want the validity of the Fermat principle, we need to take in all the light rays should be taken in a same plane. And the second one is Snell's law. So I'll explain Snell's law. You can see, for example, if you taken it is your surface separating two media, and here if you taken it is a medium one, and it is you can take as a medium two. A refractive indices of this one you can take an N1 and refractive index of this one you can take an N2. Let us light ray travels from medium 1 to medium 2 and it is incident on the surface, and here you can take it as point of contact. So this is point you can take as point of contact. Now at the point of contact we need to write a norm. So it is you can take as a norm. Then light ray will be bends at the normal. Therefore, it is you can take as incident ray, and it is you can take as a normal, and it is you can take as a refracted ray. See, incident ray, normal, refracted ray, all should be taken in same plane. And second one is Snell's law. According to this one, incident ray makes an angle with normal. You can take an angle of incidence. And refracted ray makes an angle with normal. You can take an angle of refraction. Therefore, N1 sine I equal to N2 sine R. Or you can take sine of angle of incidence divided by sine of angle of refraction that equal to n2 divided by n1, or you can take in n2 1 means sine of angle of incidence and sine of angle of refractions ratio is remains constant for a given pair of media. This law you can take next as Snell's law. So laws of refraction point of view, two different laws we need to take in. One is which is obeys of Fermat principle, that is incident ray, refracted ray, normal at the point of incidence to the surface separating two media lie in a same plane. Second one, for all media, the ratio of sine of angle of incidence to the sine of angle of refraction is constant, equal to relative refractive index of incident medium relative to refracted medium. Then we can go with the optical length. Optical length, they are given the distance traveled by light in vacuum or air to travel a distance L in the medium during the same time in either air or medium. So that is we need to take in with the help of two media. Now you can see. So I'll take in two different mediums to understand this concept. So one is a rarer medium. Let us you can take in it is your one medium. And here I'm taking one more medium. Okay, two different medias I will take. Let us you can take in it is a rarer medium and it is a denser. Rarer medium refractive index you can take in as N1, and denser medium refractive index you can take in as N2. And say for example within a time t, the length traveled by light in this rarer medium. So within a time t1, So within time t1, the distance traveled by light in rarer medium. The distance traveled by light in medium 1 and medium. In medium 1. You can take it as to be as L1. So L1 is nothing but velocity of light in the medium. You can take in V1 times of time of light, you can take as to be as a T. And here, so length traveled L2, that is velocity of light in the medium 2 times of time T. So now what they are given, so during the same time, now here time you can take as to be as L1 divided by V1, that is your time t, and here L2 divided by V2, that is your time t. Now you can take and time is saying, so L1 divided by V1. So refractive index I am given, refractive index N1 is nothing but C divided by V1, and refractive index N2 is nothing but C divided by V2. Therefore, yeah, V1 you can take as V as C upon, so C upon N1, that must equal to L2 length traveled within a time t divided by C upon N2. Therefore, C and C get cancelled. So N1 times of L1, that must equal to N2 times of L2. So if N1 you can take in as to be as 1, means it is air medium. So if it is air medium, so then you can take in this length is optical length. So optical path length, that equal to n value we need to take in as to be as n1 value taken as to be as equal to 1. Therefore, L1, that equal to refractive index of denser medium times of length traveled in that given medium. That is your optical path length. Okay. So it is your optical path length. Simply, optical path length in air medium much greater compare with other medium. So here you can write one more point. So optical path length in air must greater compare with optical path length in any medium. So in any medium, because velocity of or speed of light in rarer, that is air medium, is maximum compared with any other medium. Therefore, you can take an optical path length in air is must greater compared with any other medium. Okay. Next, laws of refraction using Fermat principle. Let us you can take here one surface we need to assume, and here one object we need to take in a given medium. So let us you can take it is your medium 1. So it is your medium 1, and here your object you can take. So it is your object. So now object initially it is at a height a from the point of interface. Now one light ray will be incident on the surface. Let us you can take in at this point. You make a point normal at the point of contact. Let us you can take in it is your point of. Now, if you're taking it is one medium and it is your medium 2. So it is your medium. So now light ray will be bends at the point. So it will be bends at the point will be like this. So at a certain point it having image. So you can take in at this point you got an image, and from the surface and the depth of the image you can take in as to be as B. The depth of the image you can take in as to be as B. Now, the separation between object and image you can take in as to be as D. Distance between object and image you can take in as to be as D. Now, see the distance between object to point of incidence. If you take in as to be as X, then distance between point of incidence to object you can take in as to be as D minus X. Okay. Now, speed of light in medium 1 you can take in as V as V1, and speed of light in medium 2 you can take as V as V2. Therefore, time to reach, so time to reach from object to image, that is you can take in first time to reach from object to point of contact. Let us you can take in point is P, the point of contact you can take in as V as a P, plus time taken from point of contact to image. Now here you can see distance traveled by the light from object to point of contact. It is x and it is a. Therefore, this distance you can take under root a square plus x square. Therefore, distance divided by speed. So under root So a square plus x square divided by speed of light in a given medium 1, that is you can take as a v plus time taken by the particle from point of contact to image. Now it is d minus x and it is b. Therefore, here distance traveled by the light ray. So you can take so d minus x whole square. So d minus x whole square plus b square divided by speed of light in a given medium. So according to Fermat, so time is minimum. So time is minimum. So but here time is a function of x. So therefore, so dt by dx that must equal to 0. So according to Fermat, t is minimum. Now here function t is a function of x. Therefore, you can take in dt by dx equal to 0. Now you can differentiate on both sides. So you got so dt by dx, then you got it is 1 by v1 times of differentiation of so d by dx of sorry dt by dx d by dx of under root a square plus x square plus 1 by v2 times of d by dx of so d by dx of under root so d minus x whole square plus b square. Now if you differentiate this one, now it is absolutely equal to 0. Therefore 1 upon v1 times of d by dx of root x. So d by dx of root x, you got 1 by 2 root x. So 2 times of a square plus x square. And x square plus x square, if you take an again differentiate, you got a 2x plus 1 by v2 times of d by dx of under root d minus x whole square plus b square. Therefore, you got 1 upon 2 root. So d minus x whole square d minus x whole square plus b square. Now again if you do differentiate inner function, you got minus 2 times of d minus x. Why? Because here the coefficient of x is negative. From this you can write over here. So 1 by v1, 1 by v1 and here 2 and 2 get cancelled and here also 2 and 2 get cancelled. 1 by v1 1 by v1 times of x divided by under root d square minus a square minus x square. That must equal to so d minus x divided by under root so d minus x whole square d minus x whole square plus b square times of 1 by v2. So see in the diagram x divided by under root a square plus x square you can take in. So this term you can take in as to be as sine I, and this term you can take in as to be as sine r. Therefore, sine I by v1 that equal to sine r by v2. Or if you multiply with c on both sides, both sides, therefore you got n1 sine I equal to n2 sine r. It is your Snell's law. N1 sine I equal to n2 sine r means the ratio of angle of incidence to the angle of refraction for the pair of media is remains constant. Like this, Fermat will be explains the law of refraction. Okay. Next concept, vector form of Snell's law. See, so here if you're taken, it is your surface and which is separating two media, and it is your medium 1 and it is refractive index of medium 2 is n2. Light rays will be incident from the medium 1 to medium 2. Like this, light ray will be incident. At the point of contact, you make a normal. Now light ray will be refracted like this. So refracted. I am not given whether it is a denser medium or rarer medium. So just it is a bending like. Let us you can take it is your angle of incidence A. And here if you taken it is your angle of refraction. Further, if you are extending in this direction, it is your I cap direction. See, where I cap be the direction of incident ray, I cap be the direction of incident ray, and R cap be the direction of refracted ray, direction of refracted ray, and N cap is your normal, direction of normal, direction of normal. See, already we know that. So we know that Snell's law is nothing but n1 sin I equal to n2 sin r. N1 sin I equal to n2 sin r. From this, if you are taken, uh, It is your I cap and it is your R cap and it is your N cap. And here you can take in as a minus N cap. Now from these vectors you can see minus N cap cross I cap. So that is you can take in it is an angle of incidence and here also angle of incidence. Therefore you got magnitude of N cap into magnitude of I cap. So magnitude of I cap times of sine of angle of incidence I. So here these are all given directions only. That's why it is a unit vector. So you can take in for sin I you can take minus n cap cross I cap you can replace with I cap cross n cap. Why? Because A cross B equal to minus B cross A. Take this equation number one. Now here you can take minus n cap cross R cap. So one more minus n cap cross R cap. That is you are taken magnitude of n cap times of magnitude of R cap into sine R. Therefore, so you can write this equation is R cap cross n cap that is your sine R. So you can take this equation number 2. Substitute equation 1 and equation 2 in the Snell's law. That is equation number 3. Now what do you got now? Refractive index of incident medium times of angle of incidence, that is incident ray direction into normal direction. That must equal to refractive index of refracted medium times of sin R is nothing but R cap cross normal direction. So it is your vector form of Snell's law. Okay. Next, see nature of bending and deviation. So before going to discuss about this one, we need to define the medias. How we need to define the media. Let us say, for example, it is you can take in medium one. So medium one, and it is you are taken as medium two. Let us refractive index of medium one is N1. Refractive index of medium two is N2. So here I am given one relation between refractive indices. So refractive index of medium one is greater compared with refractive index of medium two. If refractive index is greater na, so then definitely velocity of light in medium 1 is lesser compared with velocity of light or speed of light in medium 2. Means if speed of light is lesser in the medium, then the medium you can take next to as a optically denser medium. If velocity of light is more in the medium, then optically the medium is rarer medium. Therefore, whenever light ray is moving very slowly in a given medium. That medium having high values of high values of refractive indices, and low speed means it having low refractive indices. See, whenever light ray travels from medium 1 to medium 2, I am defining refractive indices. If refractive index is 1 is greater compared with 2, na, then medium 1 you can take as a denser medium. So it is you can take next as a denser medium. So denser medium refractive index is great. And medium 2 you can take next as a rarer medium. So rarer medium. Now whenever light travels from rarer medium to denser medium, like this. Whenever light travels from rarer medium to denser medium, so you make a normal. So it bends. If surface is not there na, it is moving in this direction. But because of the surface, light ray will bend away from the normal, like this. So whenever light ray travels from denser medium to rarer medium, the light ray will bend away from the normal. So here you can see incident ray makes an angle with normal, you can take an angle of incidence. And refracted ray makes an angle with normal, you can take an angle of refraction. And it is your angle of incidence only. So then certain amount of angle the light ray will be deviated. So there it is your deviation. Now if it is angle of incidence now, and here also you can take an angle of incidence. So in this case angle of incidence plus deviation that equal to angle of refraction, or angle of deviation equal to angle of refraction minus angle of incidence. So it is the first case. Now here light ray travels from denser medium to rarer medium. Apply here Snell's law. So you got refractive index of denser medium times of sin I that equal to refractive index of refracted medium times of sin R. Therefore, so here you got R is nothing but sin inverse of n1 divided by n2 times of sin I. So so the deviation formula here you can write R is nothing but sin inverse of sin inverse of sin I of n1 divided by n2, sin inverse of n1 divided by n2 minus angle of incidence. Okay. Now here you can see. So let us you can take in it is your medium 1 and here you can take in medium 2. And refractive index of medium 1 is is lesser compared with refractive index of medium 2. Means a refractive index of medium 1 is a rarer medium and medium 2 is a denser medium. So medium 1 is a rarer and medium 2 is a denser. Whenever light travels from rarer medium to denser medium, at this point you make a normal. Whenever a surface is not there, na, light ray will be moves in this direction. Because of the surface, light ray will bend towards the normal. Light ray will bend towards the normal. Therefore, incident ray makes an angle with normal. You can take it as to be as angle of incidence. And refracted ray makes an angle with normal. You can take an angle of refraction. And here we need to consider the deviation. In this condition also, so deviation, whenever light travels from rarer medium to denser medium, angle of incidence is greater. Therefore, deviation you can take angle of incidence minus angle of refraction. And here also you can take n1 times of sin I that must equal to n2 times of sin r. So therefore, angle of refraction is nothing but n1 divided by n2 times of sin I. Therefore, deviation you can take angle of incidence minus n1 divided by n2. No, sorry, it is a sin r. So therefore, r you can take sine inverse of n1 divided by n2 times of sin I. So hence, here r is nothing but, so you can take sine inverse of n1 divided by n2 times of sin I. That is your deviation whenever light ray travels from rarer medium to denser medium. And here once again I'll written the deviation formula. See, whenever light ray travels from denser medium to rarer medium, angle of refraction is greater compared with angle of incidence. Therefore, angle of refraction you can take sine inverse of n1 divided by n2 times of sin I minus angle of incidence. So keep these formulas in your mind while solving the problems.